What if everything you've been told about autism is downstream of the real cause? Not just genetics, not just gut health, not even just vaccines, but a failure of light. According to neurosurgeon Dr. Jack Kruse, autism isn't a modern mystery. It's an ancient glitch, a signal lost between the sun, your mitochondria, and the way we now build life in the dark. This episode will change how you think about medicine, biology, and maybe even your own story. We're talking atavism, photobiomodulation, recursive light loops, and why your red blood cells might be better described as antennas than oxygen shuttles. I've got Dr. Jack Kruse with me, neurosurgeon, quantum biologist, systems disruptor, and probably the only person alive who can explain how sunlight, mitochondria, circadian rhythms, and DHA are either saving your life or slowly erasing it. Welcome to the Longevity Formula, the podcast where we explore a new era of wellness through the pillars of faith, light, movement, mindset, nutrition, and science. I'm your host, Dr. Brandon Crawford. So what happens when a brain surgeon starts asking first principle questions about autism, mitochondria, and why red light might matter more than red meat? None of this was ever presented in my life.
It's right? It's not going to be presented, Brandon. And the reason why is because you have to realize that this is your punch in the mouth from science. They don't want you to know this because you have to realize something. The more of this we know, the more you're actually uncovering the paradigm that's out there. So they're trying to keep this under wraps. They're not really interested in solving it. I mean, all you have to do is look at the numbers. When you go from 1 in 100,000 to 1 in 27,000 in Southern California with autism, that should be a huge sign to you that, hey, this is a problem. And then let's extrapolate the numbers further. What does this really mean from an evolutionary perspective? If this trend continues, the slope of this line continues, this is cognitive de-evolution. So as I mentioned to you before you hit the record button, what autism is to everybody who's in this field is a little bit different story. And I find out that the flavor depends on what has been uploaded in their brain and they believe. See, I don't believe anything you believe at all. Why? Because I'm way past it. And where my perspective comes from as a neurosurgeon, I know what I was taught to believe about autism 40 years ago. Then I see how it's morphed. And then when I dove down the biophysics ladder and started to realize that there's a recursive loop in the brain that works on light, that's in brains that are like yours and mine. So then you need to realize, okay, what happened between, say, our nearest ancestor and us in that period of time that we don't really have any good data for? Well, there had to be a period of time when we went from non-talking to talking in the hominid species. So it would only make sense that people that had problems with neurulation in their thalamus had another way to communicate. So when you see humans that can't communicate properly with their environment or with other species, meaning other people in their own species, this is a strong data point that autism is an atavistic effect. In other words, it's not what we all think it is. And then you have to ask yourself, okay, what is Archimedes' lever for evolution? And that's where it gets into the discussions that I just told you about that I had with Nick Johomes on his podcast, where light is Archimedes' lever. But all of us that are in healthcare, we're always taught that it's a biochemical paradigm, that everything you learned in the biochemistry book is actually how cells work, and it's just not true. And one of the easiest ways to prove it's not true is when you open the biochemistry book, realize that just about every biochemical has an absorption and an emission spectra. Well, let me ask you a question. This is very simple. Whether you believe in God or evolution, why the hell would each boxcar of biochemistry have a barcode for light on it if light wasn't part of the equation? That's really the simple answer. So then it's incumbent upon you, Brandon, as a guy that's in this space, to say, I didn't know about that. Nothing in my training actually even hinted that this was an issue. That's a good sign for you, because then what are you doing? This is when you need to become a first principle thinker, because you go from the known to understand the unknown. And unfortunately, in the centralized paradigm, especially when it relates to autism, Nobody does that. Everybody just wants to say, oh, well, it's the vaccines. Well, it's not. The vaccines are downstream of this effect. Do they definitely exacerbate the situation? No question about it. Why? Because they're mitochondrial toxins. Now do a hard stop. Where does this recursive light come from? It comes from mitochondria. We already know from the biophysics literature, literally in Roland Van Wyck's book and Fritz Pop's work. These are the two guys that have done the best work in this space to give you the basics. That mitochondria, through metabolism, creates ultra-weak biophotons. Well, then the question becomes, if you're an autism guy, which it sounds like you are, you're like, okay, what is the spectrum of light that mitochondria make with different versions of autism? Like, how does this actually work? And then you ask yourself the next question, well, I know that the Krebs cycle produces more ATP than anything else. And we also know that kids that have autism tend to love carbohydrates. They don't like fats. They hate vegetables. What would that do to the light signature of these kids? And how does this affect neurulation? Like, there's no mystery how the brain forms. All the cells that become the neocortex come from the thalamus, okay? The thalamus is the sensory center of the brain. Yes. So if there's a problem with migration while this child is inside its mother, completely hypoxic and surrounded by amniotic fluid, what kind of light signal is being made actually in there? And it turns out, when you ask these questions, you begin to realize, where does autism really start? And this was, Nicole's punching them out. It was Sergey Brin and Nicole Shanahan's germlines that set the stage for the autism. When Echo got popped with the MMR after she was postnatal, what did that do? It rose the heteroplasmy rate up, changed, and that's a mitochondrial effect. That changes the recursive light signal. And then what happens? Then you have a reversal of the neurulation that went on in utero, and then you're back there. Here's the good news of the biophysics of that story that Doug Wallace has told us. If you can reduce the heteroplasmy, you can actually fix the problem the same way that it came. So if there is a mitochondrial toxin, whether this be aspirin, whether it be light, whether it be pesticides from a golf course, you name it, it doesn't matter what it is, because all stress in the human body actually acts on the same pathway. It's the two pathways between the autonomic nervous system, and that's especially true postnatally. It's different in utero. The key is that we should be teaching doctors how to treat that so that we can take monkeys that don't talk into silly talking monkeys again. And the interesting part of this is why all kids with autism have sensory processing disorders. It's almost, most of the professionals in this space, they actually aggravate the shit out of me because this is basic neuroanatomy. Everybody knows that the thalamus is the center of all sensation in the body. Well, it's clear that this process is broken in these kids, meaning their mitochondria are a problem, and we should be focusing in on those tracks. Those tracks are bidirectional. And remember what I told you, not only bidirectional in terms of the neural and the vascular wiring, but I'm telling you there's a recursive loop between the mitochondria and the outside world. Like, yes, when you say telepathy, mitochondria clearly are telepathic because they're the wireless connection between the sun and the colony of mitochondria and us. And that's exactly what's happening. The sun comes in, programs all the things in our cell, and then what does the cell do? It emits biophotons at a very small scale, and that's actually what innovates life. That's actually what drives all the neurulation pathways that are in these broken kids' brains, or whatever you want to call them, neurodivergence. I don't give a shit what you call them. It doesn't matter, because the big thing that people have to get right is the 100,000-foot view of actually why the pathophysiology happens. It's not a biochemical problem. It's not a genetic problem. It's a biophysical epigenetic phenomenon caused by a problem with light.
And this is the part where, none of that was ever presented to me. And I love this because what the largest part of my training was
looking at neurological imbalances, right? And so we can see in QEEG coherence studies, we can see in some fMRI studies where there's certain areas of the brain in autism that have not fully developed, and we see weak long-range projections in areas such as the right insular cortex, specifically more in that right hemisphere. However, in the left hemisphere, we do see patterns where we see this dominance, right? We see increased short-range projections, we see higher densities, et cetera. And so the majority of my training was looking at those things. And then in developmental functional neurology, we look at, okay, well, how does the brain develop? And so it goes all the way back to sensory integration, primitive reflexes, and these things, right? And so we've developed this track in the rehab space, how to stimulate these physical receptors and correct these imbalances. However, while that works very well for some, there's so many that don't respond like we would like. And then when we started folding in using, photobiomodulation and talking about circadian biology and fixing circadian biology in these individuals, our success rate went way up. I mean, it made a huge difference. So I guess my question to you is, do you think that the poor light environment in utero and then the continuation of non-native EMF exposure in these individuals is what's driving these neurological imbalances? Or do you think the neurological imbalances are even a part of this?
I think what you're doing, let me try to give you this analogy that I just used with Sabine Hazen on another podcast. You guys in your space are looking at autism as the movie screen. Uncle Jack looks at it as the projector that's emitting the light. And your perspective actually needs to change to understand this. So when you say the baby's light environment, people will listen to this that are not sophisticated because they're like, well, the baby's inside its mother. There's no light there, but that's the problem. There is light there. And the baby is sensing the light of mommy, but the real light that I'm talking about is the light that's in the mitochondria of the stem cells, sperm and egg, before they unite. And then after, when we get through all the phases that happen before we get to the branchial cleft levels, when you're starting to see neurologic organization, that's the light show that I'm interested in. And because that's the light show that sets up morphogenesis, it sets up organogenesis. And autism functionally is an embryologic problem. So let me explain something to you that most people don't really know and spend a lot of time about kids with autism. Since autism is an atavistic effect in my framework, my decentralized thesis, that means that the kids' myelin levels are radically different than they would be normally. Remember, myelin in the central nervous system is radically different than the peripheral nervous system. So when you have white matter changes, why is this a big deal? What do we know about the Cambrian explosion and the great oxygenation event? There's no myelination prior to that in the first two domains of life. When the two domains of life come together and you get eukaryotes, you get mitochondria, you get chloroplast, what effectively happens in the central nervous system of complex life? One of the first effects is you use the TCA cycle to create myelin. What does myelin do? Two things. What you learn about, it's an insulator for the action potentials, but that's not really the important part. But it also turns out to be a proton conductive mechanism so that it increases ATP efficiency. Guess what myelin is tied to? ATP efficiency. So when you begin to understand the biophysics of this, that in order to myelinate a brain so that it works perfectly well, that you have to have these things in order in the embryo. They're already disordered in kids that have autism. Now, how bad the disorder is, it's like a train station in New York City that has 37 different stops. So the kids that you take care of and you have big wins with, those are kids that the defect isn't as bad in this energetic platform. The ones that are really bad are difficult to deal with. The reason why you have found photobiomodulation works is because guess what it does? It actually improves myelination. That's one of the key things. And what do we know about neurulation? It depends on myelination to operate perfectly. Okay? That's a big key. So when you begin to understand these basic concepts, then you go, okay, what's the other effect of photobiomodulation on the human body? It actually renovates heme proteins. It fosters heme to be in the +2 state. What does that mean? That means that hemoglobin with a +2 oxidation state can carry oxygen. Do you know that hemoglobin, when it's in a +3 state, can't? And do you want to know what that means? That means that the brain doesn't get the blood it needs. Remember, something you learned very early on in your training. The brain gets 20% of the cardiac output, whether it's inside mommy or us. So what happens if you get the 20% cardiac output in utero, but most of the hemoglobin is methemoglobin or can't carry oxygen well? Do you think neurulation is going to go off the way it would go off in a regular brain? See, you're already starting to smile. Now you're beginning to realize why this is a big deal. And then when you parse the next level of this, say, okay, Jack, let's talk about the optical density of hemoglobin. Well, it turns out it's 250 to 600. We're talking about light that's in the UV and just getting into the red range. Hemoglobin has a sharp cutoff at 600. So what does that tell you? Is hemoglobin the red light story that you think it is? No. Turns out it's actually the story of controlling oxygen. And it turns out when you're building a brain inside your mama, hypoxia is the key, okay? What does hypoxia mean to you when you hear it? Generally, it gives you a negative connotation. But it turns out this is absolutely the key thing that the brain needs to grow. Absolutely. Why is that? This is something I know you don't know. What did Fritz Popp and Roland Van Wyck clearly find in their careers? That oxygen is associated with UPE formation. So what does that tell you that you need in this neurulation standpoint when you're building a brain? That the type of UPEs that the brain makes when you're hypoxic inside your mother is exquisitely important to get proper migration. It also means that the spectra is tight, and it also means it's more monochromatic than it would be like what we're experiencing now outside. So the light show that controls this atavistic effect, all you have to do to change it is change that spectra. And it turns out that's what epigenetics has been telegraphing us since those Duke studies in 2003. But people who are working in your space don't know this biophysics. They don't understand how to link it to the embryology of the brain, and they certainly don't understand actually how cells truly work from a stem cell perspective. So, for example, I just did a consult with a patient early this morning who was having problems with fertility. That's why they called me, and one of the questions they asked me, because they went and spent thousands of dollars in Europe about having this baby using stem cells. I said, did the doctors that were going to charge you these thousands of dollars tell you what controls the stem cell depot in humans? And the answer was no. The answer is nitric oxide. So what does that mean? Nitric oxide is created by generally violet light, UVA light. That's what happens. And it works at very small scales, and that's how you tap into it. So when you think about the thalamus in that baby, I don't know, say month 1 or 2, you have bursts of nitric oxide being made from the mitochondria at that level that are tapping those neurons to become neurons and then migrate, the way the plan tells it to do. Well, if that process is out, if that mother's mitochondrial DNA cannot make UVA light properly at ultra weak biophoton level, what would you predict that you think the problem is when you hear this framework that I'm giving you? You go, okay, that makes total sense why, kids would have a problem in their neurodevelopmental delay. When you realize that nitric oxide doesn't act globally, it acts extremely focally, then you begin to say, from a brain's perspective, make believe, do what Einstein did, make believe you're a neuron in that thalamus that's neurulating. What happens if the zip code for nitric oxide is different everywhere? Won't you get all the kids that you can help and can't help? In other words, you get a random distribution over a period of time because it depends on that recursive loop. And remember, that recursive loop also changes based on where mommy and daddy go, where they live. What do we know clearly from Fritz Popp's work, from first principle thinking? You don't want to live in New Jersey and you don't want to live in California. Why? because that's the place where people get autism the most. So then you have to ask yourself the question, Brandon, why is that? And then it's very simple. When you go get a meter and you go to those places, you find unbelievable amounts of electromagnetic pollution. So let's ask the question that you should ask. Jack, do we have any first principle papers out there that show that you can change metabolism with light? Then I'll introduce you to a lady named Nora Volkow, who is Trotsky's granddaughter, who's the head of the NIDA, appointed by Fauci. She did a paper in 2011. Do you know what it shows? When you put a cell phone up to the side of your head, it increases your blood glucose and your insulin. No food needed. So let me ask you a question, since we're going along with this. Do you think if you had a constant source of glucose and insulin in your body, that it would change the UPE frequency in cells?
Absolutely.
Okay, so now ask the next question, because I'm telling you, that's the level of sophistication that Uncle Jack operates in. Why? Because I understand the biophysics and I can link it to the embryology. Why? Because what's my day job? I'm a neurosurgeon. I know this stuff inside and out. The stuff that I didn't know 20 years ago was anything about Alexander Gurwitch, nothing about Fritz Popp, and literally nothing about Roland Van Wyck. And what did I have to do? Roland Van Wyck's book wasn't out 20 years ago. I spent over $100,000 transcribing papers from Japan and Russia to figure this shit out before that book's out there. You, my friend, can go buy Roland Van Wyck's book and literally read from 1927 all the way to today and see just how much you missed. And then you'll go, so this is the reason why I didn't really learn this, because guess what? The guy that controlled the budget, Anthony Fauci, made sure we always focused on RNA and DNA, not the mitochondrial DNA. That's why you never learned about UPEs. That's why you never understood this recursive light. I when I sit down and talk to clinicians in this space, just like I did with Nick, and I tell them what I just told you, they look at me like I'm an alien. Like everything I just told them is not true. And then when they go find out that it is true and that everything alive emits ultra-weak biophotons, it kind of blows your whole paradigm up, doesn't it? Because you don't really know shit. But yet, you're the expert taking care of these kids. But to your credit, what did you find? This is the best thing that I think that you said in this podcast. Jack, it's crazy. When I use photobiomodulation, I find that I can improve these kids. Why? Because photobiomodulation increases myelination. Myelination improves neurologic function. The brain is still plastic in these kids, so that means that you can finish the process that was never finished in utero.
Absolutely. And not only that, but within photobiomodulation, what I'm really interested in now is you're talking about sub 600 nanometer wavelengths, violet. And so we do regenerative medicine procedures as well. And I've started to incorporate green in these procedures. And when I did that, the results actually went up again. And I'm curious now. Well, this is what I'm. Tell me.
Green light stabilizes hemoglobin. It stabilizes the alpha and beta chains. Yeah, it stabilizes the alpha and beta chains, and it actually helps. So generally, this is something that the biophysics community doesn't really know yet, because I'm actively fighting with them on Twitter just about every day as well. They believe that most nucleated cells, you know that red blood cells aren't nucleated, so that means they don't have mitochondria. They're like, well, how the hell does a mitochondria, I should say, how the hell does a red blood cell actually make biophotons? But there's papers out there that show, and they all stem from Fritz Popp's work, because he did look at blood under photomultipliers. Blood actually emits UPEs by itself. So it turns out when you stabilize the alpha and beta chains, it actually creates more ultra-weak UV biophotons. So it turns out red blood cells, the reason why they're really special is because they emit almost monochromatic UV light. And we do it in a different way. And it turns out the biophysics of the alpha and beta chains actually is what changes all of that light show. So, for example, when you have somebody who has sickle cell, or you have somebody who has thalassemia, or for argument's sake, say you have somebody that's got microcytic anemia due to an iron problem, okay? Those biophoton signatures are all different when you look at them under examination in a lab. And that's the information that needs to come out, and realize that what is a red blood cell fundamentally in Jack's decentralized thesis for medicine? It is the radio antenna that connects the sun to your colony of mitochondria. Why? I think everybody knows that red blood cells carry oxygen. Oxygen is the terminal electron receptor for your mitochondria. That's what you're designed to work best with. But it turns out all the oxygen that you don't use in metabolism, guess what? That's actually what creates the light show. So when you use the TCA cycle maximally, and the green light is tightening everything up, that tells you that the spectrum that you're going to release into tissues is going to be optimized so that you get perfect neurologic function. And this should make teleologic sense to you because of the things that you learned about the brain, that one of the things that separates silly talking monkeys from everything else is that we get 20% of our cardiac output. You know what that tells you? That you better know a shit ton about red blood cell embryology and really what and where hemoglobin comes from, heme proteins. And that's why I had to take Nick to the great oxygenation effect. Why? Nobody in medicine knows about how the GOE really sculpt us, because that's where we began to first be able to use light. And when I say light sculpts life, this is actually how it happened. And the guy that's gotten closest to that story, in my opinion, on the biochemistry side is Nick Lane. He wrote a whole book on oxygen. But the thing that he does not understand, he doesn't understand any of the biophysics. And the biophysics are just coming out. And I understand it's really hard to blow your own biochemistry paradigm up, but the GOE is where you have two domains of life, and we come out of that. So we have to have ways of dealing with oxygen. And the real key metric is understanding what Pock and Roland Van Wyck found. If you don't have oxygen, you can't make ultra weak biophotons. So what, by first principle thinking, does that really mean? It means that life sculpted complex life.
Right.
And that's the reason why for 3.8 billion years, life was either archaea or bacteria. It's not until we gain the possibility of using this toxin in the environment, namely oxygen, protecting it enough so that we can create light with it, and that light inside of us actually then created another system. That's the recursive system you and I are talking about. And that explains the reason why, when you listen to what I talked to Rick Rubin and Huberman about, what was the impetus for us internalizing melanin inside? Well, here's your answer. And when you begin to understand, myelin actually shows up around the Cambrian explosion. Like, how do you build complex neural systems? It's got to start with the basic building blocks. And what is myelin? Myelin is not only an electrical insulator, but it's also a source of light hydrogen, protons, that you can use to feed the ATPase. The more that sucker spins, the more complexity you build. Actually, it tells you also you can use more oxygen. Why? Because the faster the spin rate of the FO head means you become more effective using the TCA cycle. When you begin to see that, you go, okay, there's a thermodynamic answer here of why life was able to become more complex. And the reason why this is important, I always tell people to go listen to the Tool song, Schism, because to understand what you and I are talking about right now, you have to understand how humans were built and how they fall apart. And in my clinic, these people are falling apart. So I'm reverse engineering all the things that I know happen between the first two domains of life and us. And it turns out the biggest mystery to this solution is what happened in the great oxygenation event, because that is where we gain the ability to truly use light. And the recipe that we're using is still being worked out. I would love to tell you that we know a lot about this process, but to be quite frank with you, we don't know enough. And the reason we don't know enough is because people like Nora Volkow and Tony Fauci have been the gatekeepers of spending money on the Watson and Crick side of biology and no money on the mitochondrial DNA side where this light is made. The DNA side is actually where the light is stored. That we know. And the recursive clocks that are there between the storage of light in DNA ties to methylation patterns, ties to histones. That actually is the magic wand of epigenetics. Again, a light story.
Yes.
And we need to get science, basic science, to those levels. So like when I talk to a guy like Nick or Nick Lane, like they think I'm an alien because they don't even know this science already exists. And this is basic science. This doesn't even require you blowing 6 neurons on understanding this stuff. But the implications of this basic cornerstone research begins to explain to you bipolar disorder, begins to explain to you ALS, begins to explain to you all demyelination, GBS. Why do people get GBS after they get some vaccinations? Well, you're probably putting 2 and 2 together already. Okay, it's pretty clear that if you affect the intermitochondrial membrane and delta psi goes down, the UPEs change. That's how you can get that disease. Is that how you get transverse myelitis too? The answer is yes. It's just like another train stop that you see in the kids that are on the spectrum. But the problem is where the defect is, meaning the zip code inside the cell and inside the organ, determines the phenotype. That's the key.
So essentially, what's the weakest link in that individual, right? Is what you're
Correct.
saying.
And then reverse engineer it. And what you've stumbled upon is one of the key things, and you probably don't even realize this. This was the key thing that happened at the end of the great oxygenation event. We innovated heme proteins. What do heme proteins do? They bury oxygen in the +2 state. They become able to carry it.
Right.
The +3 state, they can't use it. Then they have to do something with it. That's how we got transferrin. That's how we got haptoglobin. All these proteins, catalase. Then what's the next layer of innovation from the GOE? That's where we get superoxide dismutases that work with manganese, magnesium, and all the transition metals. Why? Because we have to have a way to protect us from the toxicity of oxygen. And oxygen is really toxic to us. If you don't believe me, ask any doctor who went back into ICUs in COVID. This is the reason why when we intubated people, we harmed them, because all of these people had +3 shifted hemoglobin. And if you have +3 shifted hemoglobin, that means you should be inside a uterus, not in an ICU. Right. And what did we do? We stuck a endotracheal tube through the vagina into the uterus in these people. And what was the ultimate outcome? Not good. Right. Remember, there's a reason why the baby's in a bag of fluid and it's hypoxic, because it tells you that when you're looking to maximally grow, remember, this is your question about stem cells. The environment has to be hypoxic. So now I want you to think about all these idiots to go to Cancun. Does Cancun have, hypoxia around? No. You are absolutely showing the public that you don't understand what you're doing. And the problem is the public is so stupid. They don't realize this whole thing as well. I said to Nick on the podcast, how can people be so gullible to go and get stem cells when you know that the baby is surrounded in a bag of fluid? I mean, you go from 2 cells to trillions of cells in 9 months. Oxygen's not involved.
Right.
But yet the baby is created. There's not one person that'll listen to this podcast that doesn't get that. So the real issue is, what happens if you lose control of oxygen in the thalamus during neurulation? Could that lead to autism? The answer is yes. Could that lead to just about every other disease where it happens? Like you said, where's the weakest link in the program? And is that true also postnatally? The answer is yes. So once you begin to understand how the process works and how we regenerate, postnatally, when the umbilical cord's cut, the ductus arteriosus closes off, the regeneration program is radically different in modern adults than it is in babies. That's when you have to use an oxygenated regeneration pathway. And who built that? Who wrote about that in the 1960s that DARPA buried? That's Robert O. Becker. What do we know about that? That you have to use heme proteins to create deuterium-depleted water to hydrate melanin sheets to create 1 trillionth of 1 ampere of current that actually turns a red blood cell into a stem cell. It actually de-differentiates the atavistic effect present, something you learned in school that is physically impossible because it breaks the modern rules of biology. Becker did a series of studies in the 1960s that proved that all those dumbasses were wrong. Like, we know the answer now, but you know what the problem is? We are blocked from that answer because Becker's work has been whitewashed from history. Why? Because he's the guy that came out and said, I can explain to you why everybody in Southern California and New Jersey has autism, but you don't want to hear it because you want to put these antennas all around to track your Trident submarines, and they canceled them. And now we wonder how it went from 1 in 100,000 to 1 in 27. I know, but I know nobody else does because they don't parse the research that's already been done. It's out there. We know. The story is a light story. It's not anything else. The only part that food plays a role here, it changes the light story that comes out of the projector. Mm-hmm. And that changes the phenotype. That's the story that people need to focus in on and study. And then I believe we can help the kids that you're struggling to help because I think we can fix them too. Even with severe autism, do I believe that there's an answer? I do. And I told Nicole that. And when I explained to her how this works, remember, she gave $20 million to a guy named Francisco Gonzalez Lima at the University of Texas to study red light and autism. Then she gave $5 million to Angie Incata to build the daylight computer. So it's not like this information, for me, hasn't been passed to somebody else who understands this plight because she's got a child this way. She knows that Echo wasn't born this way, but do you think that she likes that her mother and father really programmed their stem cells to set them up for this? And when you realize the ultimate irony, she's the patent attorney for Google and he's the guy ahead of Google. They're actually creating the 1 in 27 people. If you don't think that that's a huge burden, it's a burden for her. It's not a burden for him because he doesn't believe it. Why? Because he's addicted to the billions of dollars.
Yeah. So this story, right? So this is all making sense to me, connecting dots, absolutely. And so essentially, we're using light. So I just started teaching my staff, and we're going through, how a brain really develops. And so we're going through POMC, we're going through the leptin-melanocortin pathway. We're going, further back than, anyone in the field has ever taught as far as developmental functional neurology goes. And so I was talking around a lot of these subjects that you were just bringing up, and I brought up the concept that red blood cells and other cells are actually acting as biological down converters, right? And that's what I think what you were describing there as transmitting biophotons and whatnot.
Well, what we're doing is we're taking sunlight and transferring it to Morse code, which is the DC electric current, and light frequencies. And we're using specific light frequencies to turn on and turn off different programs that are in biochemistry. Like, all of biochemistry happens spontaneously, but it needs a thermodynamic lever. Like, I like to call it Archimedes' lever, in order to get the physiologic task done that it wants. Like, if you want the PPP to operate, you have to use a certain frequency of light to get it. When you want the TCA cycle to operate, you have to make sure that your heme proteins are in a phenomenal position. And then I think when you teach your staff about the leptin-melanocortin pathway, you need to take it all the way back even before insemination. Understand that fertility and fecundity are controlled by leptin, by the leptin-melanocortin pathway. And here's the big take. This one I think will really help you and your understanding and really your staff, because you guys are interested in this. What's the key thing that you need to understand about leptin based on the story Uncle Jack just shared with you? There is data out there that shows the absorption spectra of leptin is 220 nanometer light. Just so you know, you pull up NASA's database, the sun doesn't allow 220 nanometer light to the surface of the Earth. So that should pose a really interesting question to you. If the key hormone that controls fecundity and fertility for man absorbs 220 light and the sun emits that, but it doesn't get through our magnetosphere, why would biology do that? And the answer is you make the light inside. And you do make beautiful light stronger than the sun. So then, Brandon, it comes incumbent upon you to understand all this stuff about mitochondrial DNA that we're talking about, because you need to understand, well, yeah, that's a big deal. And then when you think about the things that we now know, that when we monitor fertilization, what happens? There's a huge burst of light. I guarantee you, when we get photomultipliers that can go that low, we're going to find out that that light is monochromatic right around 220.
That's rather interesting. Definitely never heard that, but that just kind of blows my mind a little bit there. So one question I do have for you, right? So you're talking a lot about hemoglobin in different states and oxygen. So then that makes my mind start to think about hyperbaric oxygen. Is this okay? So let's go into that a little bit. Help me understand use cases, non-use cases. You know, should we use it? Should we not use it? What's going on there?
You should never use it, with the exception of understanding. So let me explain the biophysics, so like you're in third grade, so you get it.
Please.
So I want you to look at my two fingers. This here is NAD. This is oxygen. So I just described to you the intermitochondrial membrane. What's this here? This is all the cytochrome proteins. Okay? Inside these two pointer fingers is a 30 million volt charge. Okay? That's normally what delta psi is. What keeps that charge in? That's the first question you have to ask. Turns out heme proteins called CCO. So cytochrome C oxidase does two things. What does it do? Creates deuterium depleted water, which is the insulator around my fingers. Okay? What's the other thing it does? Controls apoptosis. So when something comes along, let's say an MMR vaccine, does this, and the 30 million volt charge leaks out. So it's like a lightning bolt at the nano, atto, or femto level. It follows the electrical resistance in the tissue to damage things distally. So what's the goal? The goal is to renovate the heme proteins so that never happens. That is the key step that happens in the great oxygenation effect. The innovation and evolution of heme proteins. So most people don't even know that cytochrome C oxidase, which controls apoptosis, because if you think about it, it makes sense when this is broken, that the body wants to get rid of that cell right away. That's exactly the reason why, because when you let that charge leach into the cell, you're discharging the battery, you're damaging everything distal to it. Do you think that that cell can migrate from the thalamus out to the cortex? The answer is no, it can't. Well, what happens if that cell never is taken out because apoptosis is broken? Do you think that that might affect other cells around it during the process of migration? The answer is yes. Why? How do we know that? Already in mitochondrial biology, there's something called the intrinsic and extrinsic pathways. Guess what? Apoptosis can happen internally, but if another cell adjacent to it sees that cells around it are broken, they also undergo apoptosis. Well, my friend, what does that mean if all the heme proteins in the stem cell that got fertilized has that defect? Voila, you have autism. That's how it occurs, because it affects migration. And if you can't keep this intact, can you myelinate? The answer is no. It's impossible. You can't use the TCA cycle. The TCA cycle has to have optimal renovation of heme proteins, which is the reason why, if you've been following me on Twitter, on my blog long enough, what do I tell you is the single most important thing to do for your health? Sunrise. Why is that? Because sunrise has the highest quality red light. That's the stuff that you're using in your clinic. That's the fake shit. I want you to use the real stuff, because guess what? When that happens, you're constantly renovating every single heme protein so that it can effectively use oxygen well. So let's do a hard stop. You asked me about HBO. The only time I believe HBO is indicated is in someone who has osteomyelitis that is untreatable by any other method. Then I think it's okay to use. But when you understand just about every disease out there has this mechanism broken, what do you think is the effect when you put oxygen on there? Because I'm going to show it to you right now. Remember, this NAD, this is oxygen. What does oxygen do? It's electronegative, so it pulls electrons this way. If you have a broken bridge, do you want to be pulling electrons across this? Because what are you doing? You're creating straight current everywhere in your body.
Okay.
Make sense?
It does make sense. So is there...
That's the reason why anybody who says ozone therapy, hyperbaric oxygen therapy is indicated here, there. You, as a patient, need to run away from these people because they are telling you, they are telegraphing to you, they do not understand the biophysics of the inner mitochondrial membrane. And this is basics. Everything that I just told you here, everybody know that oxygen is the second most electronegative atom on the periodic table to fluorine. But it allows electrons to move, which is why we use it. What else is unique about oxygen? It's paramagnetic. That means it's drawn to magnetic fields. Why is it there? What's right next to the ATPase? CCO. There's the ATPase has a spinning head, creates a magnetic field. Oh, look at that. Electromagnetism. So that tells you that the amount of oxygen in our system is quantized to the light in the system. So if you go adding oxygen, what do you think happens with the light? You create huge amounts of light. And what did Fritz Pop tell us? He told us it's very unusual. When I study prokaryotes, they emit 5,000 times more light than eukaryotic cells. Here's the other interesting thing. When people get sick, their cells emit more light too, just like a bacteria. Now you should do a hard stop, Brandon, and go, well, shit, isn't a mitochondria used to be a bacteria? Doesn't this make a lot of biophysical sense?
It does.
Voila. So
Absolutely.
When people tell me we don't know, oh, we know, bro. We know. First principles thinking, we know. But the problem is you didn't get that curriculum in your schooling, just like I did. And there's a reason for that. Because the people that created Big Pharma don't want you to know this information.
Right. So is there a scenario to where we could go about a process to repair the TCA cycle, repair the mitochondria, and then use oxygen in safe ways?
After the regeneration is fixed. Once you fix the electrical wiring diagram, remember, we come out of our mother's vagina, they smack us on the ass, cut the cord, then we use oxygen. But you have to be able to use oxygen. I'm telling you that kids that have neurodevelopmental delay can't.
Right.
And this is the reason why they're always drawn to carbs. Because guess what? That runs other programs. So what are they telling you? They have a Warburg metabolism in their brain because their brain cannot use and burn fat. So it's incumbent upon you to understand that little wiring diagram that I just showed you and why it happens. Okay? How do you change the oxidation state of iron to be able to use the TCA cycle? This is the most shocking part of the story. It's not with food. You do it with light. So do you know what blue light does to oxygen? I should say to iron? Turns it to a +3 state. That's the reason why these kids have a problem.
Absolutely.
That's why their parents have a problem.
Yeah.
Guess what red light does? It turns it to a +2 state. So what you need to do is you need to get their circadian biology right, light and dark cycles, because that's how it starts. And then what you do is you renovate their heme proteins every day. Not with your light in the clinic. You tell the parents, you're going to get this kid up and you're going to walk them on the beach. You're going to get them out here in the sun. And the worse the autism is, the more they need to do. So it's not 15 minutes for these people. Like you and me can do 15 minutes. Some of these kids need to do 3, 4, 5, 6 hours. So does that mean the nuclear family may have to break up and daddy has to stay home in Southern California and New Jersey while mommy goes down to the Riviera Maya or Costa Rica or Mexico? The answer is yes. Is that inconvenient? Yes. But you chose to have the fucking kid to begin with. Sorry. Right. That's the problem. I always tell my members that it's always about if you're not good enough for yourself, who you good for? There's one corollary to Uncle Jack's rule. When you have a child and the kid has a problem, the child is primordial. You need to do everything possible to fix this problem. And when people tell me that we don't know how to fix these problems, it infuriates me, because we do know, it's just not well known. And there's the difference. That's why I tell people, I don't spread disinformation. I spread missing information. Things that are absolutely axiomatically known, published in the literature, but nobody puts them in the framework so that you can understand the phenotype of the diseases that you see in your clinic and I see in my clinic.
So, I mean, that resonates with me. So about 8 years ago, I actually took my family, we did a sabbatical in Costa Rica, and we were going to be there for a long time. We ended up being there for about 3 months, and then there was a business project in the Middle East that pulled me back. But so I've always had primary hypothyroid and Hashimoto's. When I was in Costa Rica, and literally every day we were on the beach for hours. I mean, and we were typically like naked or like very little clothes on the beach. And then if we weren't on the beach, we were running around, hiking in the jungle, etc. I went into full remission.
And I was not. Why though? Do you understand
why? Now,
why?
But then I did not. Right.
Yeah. So just so you know, and most people don't know this, and I'm glad you brought this up, because this is a beautiful tie-in to the story that you really wanted to talk to me about, which autism is. People don't understand this. Hypothyroidism is a preconditioned state, if a woman has it, that she's going to have an autistic baby. Why? Did you know that hypothyroidism is associated with demyelination?
If you say that, but I didn't know that.
Absolutely true. There's papers out about it. So when you're already in a demyelinated state, do you think that your stem cells are not picking up that programming? The answer is yes. Now, here's the other interesting thing, is T3 is needed for neurologic function in humans. Yeah. What's the other big link? Is everybody that has hypothyroidism has a huge problem handling iron. Wow. Now, doesn't that begin to fit with what we just talked about autism? Remember, this is a totally different disease, and now you just brought this in. And the reason I'm glad you did this, because this is the spectrum of chronic medical conditions. When you improve this, you can avoid the autism. Why? Because can you give a kid an injection if they have proper neurulation and proper? Yes, there are people. I know this is going to offend many kids and families that have autism. It's true. There are kids out there that took all these jabs and didn't get it. And the reason why is because the process in them wasn't broken. But I can tell you that number is really, really small. Back in the 70s, 80s, the number was huge. Now it's changed. Why? Because our environment now is filled with blue light. Our environment is filled with all the things that Becker warned us about. So what does that do? It's fundamentally changed the oxidation state of iron. This is the reason why you hear me on podcasts. In fact, I'm looking at it now. My Robbins Pathology book from 1986, that's right on that shelf. In that book, there's a line in a paragraph that says that Hashimoto's thyroiditis is extremely rare cause of hypothyroidism. This is 1986. Today, it's the number one cause of thyroid disease. So you have to realize that hypothyroidism and autism should be discussed all the time. And the fact that you brought it up is a beautiful thing, because it explains exactly what I'm trying to share with you. The lack of control of oxygen is tied to the bad biophysics of iron. And it turns out hypothyroidism is one of the key things to study to understand truly what's happening with people and kids that have autism. And you'll begin to find out that alters their metabolic rate. I think you know this, that anybody who's got hypothyroidism has a different metabolic rate. What does that mean in the decentralized framework that I just talked to you about? It means that the UPE frequency and spectra is different. So it's not the same. So why would you ever expect anybody to not have a problem from an epigenetic standpoint who's got this disease? And the reason I love what you just said is because you just proved my point, that if you go to a place like Costa Rica at the 9th North latitude, you're constantly around UV and IR light, which does what? Renovates the heme proteins and makes POMC and alpha MSH, you just built Becker's regenerative current. So what did you do? You fixed this problem completely.
Right.
And you did it with light. No, you didn't do it with anything else at all. In other words, this is offensive to the big pharma answer because they don't want to hear this story, Brandon. They don't want Brandon and Uncle Jack talking about this, and they certainly do not want us talking about this when we're talking about autism.
Right.
I mean, I'll tell you another link. I'm going to tell you another link to this story that you'll probably really enjoy. Do you know that the myelination problem for hypothyroidism, the most common disease it links to is Parkinson's disease? And then you know what else Parkinson's and hypothyroidism links to that nobody likes to talk about? Melanoma. Do you know that people that have these diseases have defects in their dopamine neurons and their melanin? Everybody knows that. But did you know the reason fundamentally why? Because the iron incorporation into melanin is blocked at a fundamental level. That's how these people get this problem. And it turns out that melanin has a very, very unusual, unconjugated atomic structure that allows it to do the things that it does. One of the key things that melanin does for us, do you know that it makes ROS? ROS actually increases ultra-weak biophotons in the UV range. That's actually where our complexity comes from. So why are we the silly talking monkeys that has melanin inside our brain when our nearest relatives have most of their melanin on the outside of their body? That's the reason they don't have frontal lobes. It's also the reason they don't talk. So what does that tell you about kids with autism? That means that they have to have a fundamental defect in iron biology, oxygen biology that affects melanin inside of them. Because it turns out the melanin directs those neurons where to go in the brain.
Right.
And the same reason why you can't make T3 and T4 is because the leptin melanocortin pathway, which goes right through your eye into that anterior pituitary. So you're beginning to see how all these things link. And your foray into this is very, very good, because this is the reason why people that have Parkinson's disease have a myelin problem. Most people don't realize this. The more myelin or demyelination they get, the worse their cognition is. You know that people who have Parkinson's are very much like autistic people, meaning that there's a spectrum of how bad cognition is in Parkinson's. Some people have zero problems with cognition. Well, that tells you that they don't have a big problem with myelination. More of their problem is on the melanin side than the myelin side. So when you think about that, I want you to think about kids with autism, because they have defects not only in the myelin side, but also in POMC as it migrates in different places.
Right.
And all you have to do to get out of nature's way is to put these kids in UV and IR environments. If you take those kids out of Jersey and out of Southern California, and you do the biohack that you did with your family, you fixed a fundamental myelin, iron, oxygen problem using light. That's really my message, Brandon, for most of the people that deal with neurodegeneration and neurodevelopmental issues. This idea, where did I get it? The biology of the great oxygenation event.
Beautiful. So the experiment of Brandon Crawford and the thyroid and whatnot, it continues, because yes, I went into literal full remission. When I came back, I started working again, working with patients, doing consulting work, all this kind of stuff. We came back. We live in the Austin, Texas area. And slowly over time, now I'm struggling again with Hashimoto's, primary hypothyroid, et cetera. And I've been curious because I do get outside a lot. I do.
Yeah, but it's Austin. Austin is terrible.
Austin, we're way north, right? So
it doesn't matter. You don't understand the EMF. Austin was one of the cities that was selected by DARPA and the DoD to be test for 5G first. So you've been living in this environment for almost 15 years, and they've ramped it up. And then what else has happened in 15 years in Austin? All of California has moved to Austin. So
that's true.
You now have people that have bad eggs, bad sperm, mixing with people in Austin while the military has built this huge area around you. And you may not know this, but the EMP weapon depot is really close to you. It's in where they blew up the, what do you call it? It's by Baylor University in Waco. Yeah. And the amount of EMF that's coming from above from Elon Musk and all the stuff around you, you've basically created a Chernobyl situation. What does that all do? If you look at my Twitter feed, and I think you look at Instagram now, yes, you could probably use this in the show notes. There's papers out there that show that 5G decreases melanogenesis in humans. So I want you to think about that. If you're decreasing melanogenesis, what do you think that does to heme proteins? Because remember, we know that heme proteins are key in making deuterium-depleted water in our systems. Well, if you can't make the water, you're dehydrated, can you ever make the regenerative current? The answer is no, because to make Becker's current, you have to take the current and down-regulate it to 1 trillionth of 1 ampere. What do we know from DARPA about melanin? They're now trying to use melanin that's dehydrated up on the ISS to create huge amounts of energy from the sun. But that's not how we use it. We hydrate our melanin because it turns out we use the smallest currents to de-differentiate our cells to regenerate. And when you have a kid that has autism, you need to understand these basics, because it turns out once you understand the basics, that's what is going to be the impetus for you to stop procrastinating, get up and move out of Austin and do what Brandon did. Go to Costa Rica for a period of time, have the experience that the defect for his thyroid disease wasn't in Brandon. The defect was in his environment, because guess what? That is a very counterintuitive thing to learn as a human, because we are not taught to think that way. That's not the way the central core of biology works, but that's fundamentally really how we do work. And I'm very appreciative that you told the audience this story, because it makes my job way easier when I try to explain how these processes work, in us, because that effectively is the key. Light is capable of changing the oxidation state of atoms. So we're specifically in this podcast focusing in on iron. Why? Because iron's one of the key ones. But remember, there's a lot of other atoms we haven't talked about yet that play roles in different diseases, and the biophysics is there. For example, one of the ones that you may be really interested in, especially for this podcast, is there'll be people out there that talk to you about lithium. And should we be using lithium in autistic kids? The answer is no, we shouldn't. And the reason why, lithium is atomic number 3. It has a very specific electronic structure. Do you know that lithium has been associated with increased myelination? But you know what the problem is? Yeah, a lot of people don't know it. But do you know what the problem is? That's the biochemical pathway. The biophysical pathway, lithium can cause hypothyroidism. So guess why the body doesn't, So guess why the body doesn't use lithium inside the pituitary gland or the thyroid? Because it has no control of the system. Therefore, biology said, no, thank you. We're going to use a different atom. So you now have this drug that's out there. And I challenge you to do this, because it's very important for you to hear this. If you go in the biochemistry literature and the pharmacia literature, look for drugs that have no biochemical pathways known. Lithium is one of them. Another one is metformin. Another one is aspirin. Another one is acetaminophen. Mm-hmm. The reason why there's nothing published in your PDR is because all these drugs have biophysical effects. So when you begin to understand that lithium can have a huge effect on people with bipolar disorder, realize that when I do MRIs and do functional MRIs on these people, I see that they have decreased white matter changes. So if they're not myelinated, does that have an implication when they're going to go crazy? Does that have an implication of how that talks? What do you know about bipolar that's tied to your sweet spot with autism? Bipolar disorder also affects the thalamus. It affects the alpha waves in the brain. Plus, these people are demyelinated. If they're demyelinated, what does that mean? They're more sensitive to electromagnetic radiation on the outside. So now you're beginning to go, wait a minute. So now I'm seeing remnants of autism even in bipolar, and I'm seeing remnants of autism in hypothyroidism. The reason I bring this up, not to be provocative, It's actually for your audience and you to see that the mechanisms of biophysics, the reason why biology made a choice early on never to use lithium in the system is because biophysically it's dangerous to do. Now, can we use it as clinicians, say if we want to have a specific effect? We would not use this in autism because even though we want to remyelinate, we certainly don't want to cause hypothyroidism because what are we doing? We'd be like a dog chasing our own tail. Makes no sense.
Right.
Now, are there other drugs that we could consider? This is probably going to blow at least my tribe's head. They're going to learn about this shortly. When 2011, when I gave my TED Talk that got banned, the reason why I gave that TED Talk is because I was trying to warn people about the GLP-1 drugs that were coming. That's why they canceled the leptin trials. This is something that Brandon needs to pay attention to. One of the interesting side effects of the GLP drugs is that they can remyelinate neurons. And,
no way.
And yes. And these drugs all come with big problems, no question about it. But do these drugs have a lot of biophysical, how shall we say, collateral damage? The answer is no. Okay. Now, are there other things? Clearly, you have captured the red light story, which I love. I just want you to use more sunlight than that. But do I think you should start parsing the literature on the GLP-1 drugs? Not for any other reason except to understand that it increases TCA dynamics so that you can create that proton capacitor and myelin that optimizes ATP function. Why? Because do I believe that could be a jump start, kind of like AAA coming out to these kids with autism, so that we can begin the process of remyelination? I don't believe it's something that we would use chronically in these kids. I think we just need to start the process, but when we put their little coconut tree in the sun, then the sun takes over the rest of the program. So that's the way I'm looking at these diseases. And I can tell you, I've never told anybody what I just told you about these kids with autism. I use this on my own farm members and our kids. And I told them, I said, look, I need to sit you down to do informed consent because generally I'm one of the guys on the internet that absolutely hates these drugs. But remember, when you're a doctor, you take an oath to do no harm. If I can find a mechanism that potentially can help somebody with a demyelinating disease, I'm going to talk to you about it. And I'm going to say, look, you're not going to get any answers from anybody else on these topics because they're not even studying this stuff. You know, they're looking to use this in different ways, but there are answers out there. And I think you've tripped over a good one. I think photobiomodulation is one of the big ones because it supports heme protein fixation or regeneration. And that actually supports getting the kids to the regenerative pathway. But that requires them to be constantly in UV and IR environments, which is the big mistake that parents are making. They're not. Right. Once they get the first step, then they need to do other steps. For example, deuterium depleted water is how I look at GLP-1 drugs in autism. Same reason. Because what is it doing? It's the electrical tape around the inner mitochondrial membrane. And I think, you know, you're a smart enough guy. I've assessed that already in this podcast. When you told me what happened in Costa Rica, I really liked that. That's the reason I decided to tell you about this. Normally, I would keep this stuff under my hat, but I think it's really important for a guy like you, since you've had this experience. I want you to take your own biohack and understand your patients that come through the clinic, because I really believe we learn most from our patients. But just remember, you are also your own patient.
Yes.
You know, and you can learn amazing things when you're paying attention, you know, to things in you. And if that gives you the insight to do different things, you know, in children that have these problems, and you can see wins, to me, that's a win.
Absolutely. So I'm curious, because there's a few different GLP-1s out there. Is there a preferred drug?
My answer to you is there probably is, but do I know what it is yet? No, because you know what? They haven't been out long enough. And to be honest with you, not a lot of people who have these problems will consent to taking these drugs because they know, they're like, Jack, you're telling me that this is a problem. I try to use the analogy we used earlier. I said, yeah, oxygen is a toxin too. But it turns out if you use it the right way and you have the heme protein protection, it actually leads to optimization. And when you actually say that, do I think the GLP-1 drugs potentially can be used? Yes, I understand they're a lot like lithium, but from what I have gathered since they've come out, because trust me, I've studied these drugs probably more than anybody you'll ever talk to, because I know where they came from the canceled leptin trials. They don't have a lot of biophysical collateral damage. Most of these are all biochemical pathway. And I think that if you use them properly to jumpstart the remyelination process, to be honest with you, the number one condition I think it has a huge benefit in is people with ALS. Why? Because the risk-benefit ratio for them is huge. They're going to die anyway. So why wouldn't you give this a try to see if this could help and then get those people to a good environment? The difference there is kids with autism are easier to bring to the beach than someone who's in a wheelchair, trying to get them in the ocean. But believe it or not, I've had patients down here who we've done that in and put them in the ocean, and they lived longer than their cohorts, 1 year longer than everyone else. So I'm going to tell you, if you have a deadly disease like that and you begin to see changes, should this be things that we talk about for people with hypothyroidism? Should it be things we talk about for people with neurodegeneration? Should it be for neurodivergence? Yeah, I think everything should be on the table. Why? Because no parent wants to have a kid that's got a brain that's damaged. And it's damaged not in the sense like we're talking trauma. It's damaged from a transgenerational epigenetic bad diet of light. That's what it's from.
Absolutely. When you were talking about lithium, it reminded me, and I'm probably going to butcher this, and I don't have the actual study or the reference for it, but I remember reading about an event where in a southern Texas town, they dumped a bunch of lithium in the water. And it was an experiment where they were seeing if it would reduce crime rates. And it did. And so then what did they do with that information? I don't know. They didn't really disclose it, but they actually had this huge, study on it where it reduced crime rates. And my correlation was, well, it must have, dampened frontal lobe activation and, made people robots. And so they didn't start, go off and kill and rob each other. I don't know if you are familiar with any of that, but now the whole story makes sense.
Yeah, because they're actually probably partially remyelinated. And remember, lithium will have the biggest effect on the people that have the shittiest redox. So the people that are demyelinated, the people that have poor action potentials, if you can improve their ability to think, which is what myelin does. People don't realize when you're demyelinated, you actually physically have organic brain damage. Like, people who have MS are not going to want to hear this. I don't listen to anybody with MS. Why? Because I know that they're not good thinkers. I want people who can fully myelinate, because when you're fully myelinated, it's an issue. And the analogy I give you, Brandon, is I tell people this all the time. Do you understand why kids are not allowed to rent a car or a hotel in the United States? Because their brains aren't fully myelinated until 25. Mm-hmm. So even corporations understand that kids are a little bit wild child. Well, the thing is, we don't think about that with people that have demyelinating diseases. Like, why do I care about your opinion? Now, of course, people will say, well, Jack, you're just an asshole. But you don't realize there's a biophysical reason why I say some of the things I do. And I would tell you, hypothyroidism is also, in my decentralized thesis, organic brain damage. Why? Because I know that it leads to demyelination. Now, it's not as bad as like ALS. It's not as bad as autism. It's not as bad as bipolar disorder, but it's a train step there. And it tells me that the person is in an environment that's not good. So it doesn't surprise me if you just take a little biohack and put lithium in it, that it's going to have an effect on the people that perform crime. The sad part is, the same story is, it may actually cause problems in other systems like thyroid, or in bone, or in the heart, or in thinking, because lithium to an excess has massive problems as well. And this is, you can see this If you look at the bipolar data and people that have been given too much lithium, they actually have humongous problems. So it's a drug that has a very, very tight therapeutic window. And that's the reason why it's so difficult to use. But it's also the reason why I would not advocate using it for demyelinating conditions like autism is one.
Got it. Okay. I know we're coming up on, how much time you have available. I wanted to shift a little bit because in the evolutionary story, we've packed away a lot of mitochondria in the brain, and that's what's given us a lot of the, humanistic abilities that we have. But we've also packed it away in the immune system. And I would like to kind of segue a little bit and have a bit of a discussion because autoimmunity is high in the autism population. Yeah, PANS, PANDAS, PATANs, all this kind of stuff. We talked a little bit about Hashimoto's, but can you help me connect the dots with these neurodevelopmental disorders and why there's such a high prevalence of autoimmunity?
Yeah, this one is probably the simplest question to answer. The brain and the skin come from the same level of the embryo, which is called neuroectoderm. Your skin is the largest organ in your body. Your skin also has more immune cells in it than any other place in the body. Okay? So what does the skin effectively do? It contains most of the T regulator cells. Those are the cells that will become all the different T cells, and those will turn on the B cells that make the antibodies that create the problem. The flip side of that is if you look at the diagram that I always share with POMC, you'll begin to notice that POMC gets cleaved into not only alpha MSH, but beta and gamma, and beta and gamma are tied to the differentiation of B cells and T cells. So when you begin to understand that the leptin-melanocortin pathway and your skin are dysregulated on your skin right here, this is called a topologic effect. So if you live in a place like Austin, do you think the signal on your skin is going to be the same as it would be, say, if you were here in El Salvador, where we have 2G and 3G? We don't have enough money to have 5G. So the signal is different. That means the UPE created from here is not bad enough for you to get this condition. So let me give you another example. If you were to assess what's going on in Austin, then you were to assess what's going on in Minnesota and El Salvador, you'll find something interesting. The sheer number of kids with autism or autoimmune conditions is much lower in El Salvador than it is in Minnesota. And then when you look at cities like Austin, Los Angeles, New York, Orange County, the latitude thing goes away. Why? Because what have you done? You've brought the EMF closer to the child, and that light is what's programming all the miscommunication with iron, the heme proteins, the SODs, all the things that allow neural migration to happen. So even if you live in Orange County where the sun is pretty decent at 33 latitude, can you use that to actually get the situation in? And you're the perfect example to prove my point. You live in Austin, which is, I think, about 31, 32 latitude, and you got Hashimoto's, which is an autoimmune condition there. You went to the 9th latitude and got rid of it. So what's the story here? The story is that autism, its base case, it's aberrant light that causes the UPE signaling to go awry. Anything that alters the UPE signaling, autism effectively is made worse by. So that's where the vaccines come in. But what's the number one problem? My opinion, blue light, non-native EMF. That's the base case of what drives the heteroplasmy rate up. And then anything that's additive to that is an issue. And the last thing I think we should talk about, since we knocked out the autoimmune condition, because nobody ever talks about this in autism, and I'd be interested to hear what you have to say after I tell you what I'm going to tell you. You know that kids with autism have dysbiosis, huge problem. And you know that that's how Andy Wakefield got canceled. We have, a little collaboration going on with me and Sabine Hazin right now about autistic kids. And I explained something to her on a podcast that you probably haven't heard of yet because it's not live, that if you understand the human gut, the top part of it from the LES to probably past the stomach is innervated by a cranial nerve number 10, the vagus nerve. That stops at the transverse mesocolon, okay?
Yes.
What takes over there is the lesser and greater spinal nerve. They're not as myelinated as the vagus nerve. Then it gets even more interesting. In the distal gut, where most of the problems for the dysbiosis for autism happens, this occurs where the microbiome is 10 to the 14th, meaning there's trillions. So it means the light show there is huge, but the enteric nervous system in humans, especially autistic kids, is not myelinated at all. So what does that actually tell you? That tells you that the microbiome light signature is much more powerful in the distal gut than the proximal gut. And how do we know this from first principle thinking? I went over Dr. Hazen with the story of Barry Marshall, which I'm sure you know about, the Australian doctor that won the Nobel Prize for Helicobacter. When I was a young resident, we used to do vagotomies on people that get ulcers, and that was like barber surgery. It was crazy. Right. But what Barry did is he proved that if he drank the Helicobacter, he could get the ulcers. What he never proved is that if you demyelinate the vagus nerve, you also set the stage for Helicobacter. What really happens when you demyelinate the vagus nerve? You open up the lower esophageal sphincter, and what do you let in? Oxygen. And that sets the tone for Helicobacter. What do we know about Helicobacter now from 1995 that we didn't know when Barry Marshall was active? Is that it creates a huge, ultra weak biophoton signature UV. So guess what's happening? You're creating UV light in an organ that's not supposed to have it. And what's the ultimate phenotype? They get an ulcer. Right. So you begin to realize that the demyelination of the vagus nerve is a big deal. So why do I say this to you? Since you're a functional neurology guy, you know that we're beginning to use vagal nerve stimulators for a lot of different cases, not only just seizures, but also dysbiosis for people that have, heart rhythm abnormalities. Why? Because the vagus nerve innervates everything in the parasympathetic nervous system all the way down to the transverse mesocode. And it turns out the kids with autism, they also have problems with the enteric nervous system. So here again, you begin to see the myelin story, and you begin to understand why the kids are going for the carbohydrates. It's because the whole entire system is broke down, and you can see the biophysics breaking down. That means that the light that the microbes are making becomes, how shall we say, disuse or noise, not a high fidelity signal. And this is the reason why this is a big case, because one of the things that Dr. Hazen has found, because she practices in LA where all these kids with autism are, and she takes care of a lot of them, she's found that they're missing certain bacteria. And I told her on the podcast, the reason they're missing that light show, my bet is those biophotons are going to be in the red range. Okay. And that fits to what you just talked about, why you're finding success using photobiomodulation. Well, turns out the microbiome actually is helping the poorly myelinated enteric cells there. But what happens when that gets broken down? The kids get dysbiosis.
That makes sense. That makes a lot of sense. So then what would happen if you just pour a bunch of probiotics down them?
Nothing, because remember, exactly. You forgot the lesson Uncle Jack just gave you. If the LES is open, does it matter?
Absolutely. No, it doesn't. And that's the thing, is that we don't do that because we don't see results with that. And we have kids coming in all the time where they're spending $1,000 a month on supplements and they haven't gotten anywhere. And that's not a surprise to us. So no child with autism should be on any supplements at all. In fact, the number one supplement you already mentioned, probably PBM. I can get behind DDW too. Those two things I think are wise, but the best thing to do is take your coconut tree that's got small coconuts that's not working too good and put it in a better environment and watch what happens to this kid. You will be absolutely stunned. And the beautiful part of this story, it'll piss some parents with autism off, but what am I telling you? That you can fix the problem you caused. All you have to do is get out of your own way and understand that the program is built into you. You can still drive the neurulation program postnatally as long as you understand how it works. And it turns out that program works on biophysics. It doesn't work on biochemistry. And that's been the big lie that's been sold to people. And I understand
that they want to blame the vaccines. I'm okay with it because it's definitely an adjunct that adds to the mix by changing the ultra weak biophotons. But if you never get to this biophoton level, you'll never understand why autism is a transgenerational epigenetic effect of light.
Your signal broke out just a little bit when you were talking about the two things that you may recommend. I heard deuterium depleted water. I didn't hear the other thing.
And photobiomodulation.
Perfect. Okay, great.
Those are the two supplements that I think everybody who's got autism should use. Why? They're cheap. They're easy to do. Ultimately, you know what I'm going to tell them. I want them in the sun because that's the best way to get back to Becker's current, to re-jumpstart the program to fix what didn't finish in neurulation. Because when you do that, we don't need to screw around with that program. It's still active. We still have neuroplasticity. As adults, the problem is the stimulus isn't as great. You're not making the light that you would normally make in a hypoxic uterus because you're not surrounded by amniotic fluid. Your ductus arteriosus is open. You still have your umbilical cord. What I'm telling you, that's the reason why tropical environments are hugely important, because the regenerative program in postnatal life uses UV and IR light. Therein lies the difference.
That's beautiful. I love that. I could talk to you for probably, 36 hours straight. I know that my viewers, my listeners, they're going to want to learn more about you, about your work. What's the best way that they can dig in and start to learn more?
Well, I think the first thing you do with me is you go on my website. My forums have literally 10 to 15 years worth of data that's all free. You just have to sign up, and then you can start reading it. And then if you want to do Uncle Jack DIY, I have Patreon blog. That's a cost of a cup of coffee a month. I will split your head open with all these biophysics. But remember, you're not going to get a lot of Uncle Jack time. Then if you decide, no, okay, I got the basics, now I want to talk to this guy, then you become a member, silver, gold, platinum, titanium. And then if you really are a tool, then you want to hire me as your doctor, lots of luck. It's going to cost you a lot of money because my time is very valuable. But do I have that available for my members? Yes. Can you hire me off the street? No. I rent my brain out only to my tribe, and my tribe are people that went through this path that Brandon just went through. In other words, I teach them the basics of biophysics so they understand where they're at, because I believe that if you don't understand the biophysics, you are always going to procrastinate. And the one thing that drives me crazier than anything else is people think they have more time than they do. Time is the most valuable asset. And if you waste it and you're not willing to move your feet with Uncle Jack, I don't want to waste my time on you.
Absolutely. I completely agree with that and understand it 100%. We'll put that information in the show notes for everyone interested. Dr. Jack Kruse, I am beyond grateful for your time today. I am humbled and honored that you came on here. Like I said, I've been studying your work for a few years now. So I'm just so appreciative, and I'm so thankful for you and the work that you're doing. Thank you so much.
No problem. It was a pleasure.